conditions are negated, then it returns this condition as true. Next, we have something called new data, which will add a new data to our block. Here, self, sender, and it will give the details of the transaction, right? In which we have sender, recipient, and sender address, recipient address, and the quantity, and it will return true. Then another static method is proof of work, which will calculate the simplest algorithm identifier, right? Which will calculate a simple proof of work, which contain leading 4 zeros, right? So proof number initialized with 0 while verifying is false. Then we'll increment that, return proof of number. Then static method for verifying proof. So we want this in a leading zeros, right? Then we have this method for mining, in which we mine the data, that is self.new data, where we'll pass the details of the this one, that is sender, receiver details, that is details.miner, quantity. Then last block will add the details of the last block. Then create a node, which will create a node for block, right? Now obtain block, in which we are receiving the details of that block, that is block data, index, proof number, hash, and timestamp, and at what time it was created. Now instantiated that class with object called blockchain. Then we perform this simple method, that is print the blockchain.chain. Then last block, blockchain latest block, and all those things, we print the details, right? When the block was mined. Understood? So this is what we did, and I'll be sharing this file. Okay. Now later words, then we created a file called, which will be working with Flask, right? So I imported these libraries, created a blockchain of class. Now this blockchain class for creating blocks and adding to the chain, right? So object, it expects a block. Then I have a constructor method, which will create a dummy chain, empty chain, and a list of current transactions. Then we will create a genesis block, right? Then let's create methods to, that is helper methods for adding a new block, that is new block, which will create a new block in the blockchain. It expects parameter as proof, previous hash, and a return, and it will return a new block, that is dictionary of new block. Then I defined a block with this following parameters, arguments, then attributes. Then reset the current list for the, after getting the details, I am resetting the current list. Then let's create a method called transactions for creating adding a new transactions to the list of transactions. So this creates a new transaction to go into the next mined block. The parameters expecting are sender, recipient, and amount. So it returns the index of the block that will hold this transaction. So here I am creating adding that list transactions to that particular current transactions dot list, right? We are done till here, right? Right, guys, everyone done? Are we done till here, everyone? Yes, sir. We will be. I will be sending. Guys, can we continue? Welcome, sir. Guys. Anil Kumar, Kanisha, Priya, Srimas, please mute yourself. Kanisha, please mute yourself. Kanisha, ma'am. Guys, look, I am facing power issues. I don't know when my system will shut down. So I want to finish it as soon as possible. Please mute yourself, guys. It's a humble request.
All the participants, please mute yourself.
Now, so let's add a property for the last block, right? So this block return self dot chain of -1. That is instance of the last block, right? Now, so let's write the hashes, right? Are we done, guys? Everyone? Now let's come to this hash method. So here what we'll do is it creates this method creates a SHA-256, right? Hash of a block. So it expects the parameter as block, which in turn is a dictionary of block. Next, it returns a string, right? Return string. Are we done, everyone? Guys, are we done till here, everyone? Now, next thing here is in the hash method, we must make sure that the dictionary is ordered. The dictionary is ordered, or we all will have, or we will have inconsistent hashes. Okay. Now, block string equals to JSON dot dumps. JSON dot dumps, that is block sort key is equals to true, dot encode. Now, so this will return hashlib dot SHA-256 block string dot hex digest, right? Now, Are we done till here, everyone? So the code, right? Now we are almost done with representing our blockchain, right? But at this point, you must be wondering how a new blocks are created, forged or mined. So we are almost done, right, for creating a blockchain and all those things, for representing our blockchain. But we all will wonder that how this new blocks are created, forged or mined. So let's understand the proof of work. Right. So let's understand the proof of work. So what the proof of work does is, yes, a proof of work algorithm. Note it down, guys, everyone. See here, I'll comment it here. A proof of work, that is POW, algorithm, is how new blocks are created, right, or mined on the blockchain. On the blockchain. So the goal of proof of POW is to discover a number which solves the problem. The number must be difficult to find but easy to difficult to find but easy to verify, right? That is computational anyone in the network, right? So this is the core idea behind proof of work, right? So let's look at a simple algorithm. I'll just open any file and try to solve this. Okay, simple, like a simple equation. Guys, I'm audible, everyone?
Yes, sir.
So what I'll do is import hashlib from hashlib, import SHA-256, right? Now x equals to 5, y equals to 0. Now what we have done is, we don't know here, we don't know what y should be yet, right? So now while SHA-256 of format, that is X mod Y dot encode right, dot encode dot hex digest of -1 not equals to 0, then y plus equals to 1. Print the solution is y equals to y, right? So when I run this, so it goes on running. The solution is y equals to 21. Now let's see hash of 5 times 21, right? $105. Sorry. No, this is not like that. So this hash, right? So it's not like this. Sorry. Okay, guys, let's continue. I'm sorry about that. That's not how it has to be. Now, so in Bitcoin, the proof of work algorithm is called hash cash, right? In Bitcoin, the proof of work is called as hash cash, and it's not too different from our basic example. Yes, sir, Anup, sir. Now, next is let's implement the basic proof of work, right? Now, what we'll do is we'll add a basic method called proof of work. Let me clear this. I'm not reading this. Method called, or we can define it here. Define.
Yes, sir.
Yes, sir.
Last proof. So it expects the current proof and the last. Now, what this does is it's a simple proof of work algorithm, right? So parameters it's expecting is last proof, which is int, last proof which is int. Now it returns again a int. Right. Now so let's write that proof. Let's initialize that proof equals to 0 while self dot valid proof of last proof and proof is false, then proof plus equals to 1. Let's increment that. Then return proof. Right. Now next is, let's call this valid method, because we require this valid method, right? So let's add this valid method. That is, it's a static method. Define valid proof. Okay. And it expects the same thing, last proof, last proof, last proof, and proof. Right. And documentation string for this is it validates the proof. The proof, that is, does hash last proof comma proof contain four leading zeros. Right, contain four leading zeros. So params are last proof, object type is int, and it returns previous proof. Then proof, current proof, it returns current proof, and the object type here is int. Right. Now next is it also returns a return statement, which is type of boolean variable, and true if correct, if valid, false if invalid. Right. Now let's define a guess equals to f of last proof last proof, and proof. Last proof and proof dot encode. Now guess hash equals to hashlib dot SHA-256 of guess dot hex digest. Now return. Are we done, guys? Everyone? Return. Guess hash 4. It will check for the condition. 4 zeros. Right? Now, next thing is, are we done till everyone? So to adjust the difficulty of the algorithm, we could modify the number of leading zeros, right? So for to adjust the difficulty of this, we could modify the number of leading zeros, but 4 is sufficient. So we will find out the addition of single leading zero makes a mammoth difference to the time required to find the solution, right? So that's why our class is almost complete and we are ready to begin interacting with it using with the STTP, right? Now let's write our blockchain as a, till here everyone done? People, till here are we done? Guys, am I audible to everyone? Guys, am I audible to everyone? Thank you. Now, so for making a blockchain as an API, so we will be going to use Python Flask framework. As we install Python Flask, right? So we will be using Python Flask framework. It's a micro framework and it makes easy to map endpoints to Python functions, right? So this allows us to talk to our blockchain, right? Now, let me make it clear. What are the things that we'll be using? 2 minutes, guys. Two minutes. Now, so we are going to use Python Flask. Python Flask. right? Python Flask framework, right? Now this will allow us to talk to our blockchain over the web using STTP requests, right? Now we will be creating three methods. We will be creating three methods. One is transactions / new. So what this method is, to create a new transaction, right, to a block. Second one is mine, to sell our server to mine the new block. Third is chain, to return the full blockchain. Now let's set up our Flask. Now our server will form a single node in our blockchain network. So let's set up our, now let's set up our Flask. Now, guys, are we done till here, everyone? Valid proof, till valid proof, are we done? Let me check if I use a text wrap. No, I haven't imported the text wrap. So guys, go up, import text wrap. From text wrap, import didn't, right? From text wrap, import didn't. So this is the library that we'll be using for our wrapping up the text. Now, so let's instantiate our node. Guys, note here, I'm starting it from the beginning of the line because it's outside of the class. It's not inside, so it's outside of the class. You can write it in other file also, but I prefer in this single file, right? So app equals to Flask name. Now next, generate a globally unique address. for this node. So node identifier, node underscore identifier equals string of UID 4 dot replace underscore with now instantiate the block. Let's instantiate the block, right? So blockchain equals to blockchain. So this is how we instantiate. So you can see that when I give that blockchain class for creating blocks and adding it to the chain. So arguments here are object, that is block, adds and displays the block. So this is why we write the documentation. Understood, everyone? Now let's next is let's write routing functions. Initialize routing functions, methods, not functions, methods. So first is at app dot root, that is, so this will be your web address, method name, mine, here methods equals to, you can use both method here, get and post, get post, or you can just use get. So let's take it guest. If we're not working, then let us change to post. Okay. So mine in the sense we are fetching the request. So get is good. So let's define a method. Define mine. Return. So what we'll do is we will mine a new block. We will mine a new block. Right? Now, next is for transactions. For transactions. App.root, that is transactions new method methods equals to post. Ref new transaction.
Excuse me, sir. You will tell from behind, sir. Here, power cutoff was there, sir.
From where, sir?
So back, sir.
From where? From back means where?
Where 15 to 20 line. Yes, so from here, sir.
From this app equals to Flask.
Yes, sir.
So here, what the motto of our is to create a web app, right? Now we are written the backend here. Till here we have written the backend, that is our code for backend. Now in front end we have to display that, right, in the web UI. So for that we will be using this Flask framework. So Flask is a lightweight framework which will help us to interact with the Python methods, right? So we'll generate a unique address for this node, that is node identifier equals to, we'll convert that UID for UUID for and replace that underscore with empty space, right?
Okay.
Now let's instantiate the block.
So what is UUID, sir?
So UID is a unique ID,
Okay.
right? Unique identifier. It's a unique address actually. So let's instantiate the block. So from here, what I've done is I created a blockchain, right? As I've created a blockchain class, right? For that, I've created an object called blockchain.
Okay.
Right. Now next, in the web address you have given that, right? .com // and method names. You'll be typing something, download or something like that.
Yes.
So that is called as routing. For that routing, we'll be using this /,
Okay.
and the method name. So when you write this, when you write in the web address, it will fetch the detail, this method, whatever this method is doing. Okay.
Yes.
Here we'll update this method later, but now let's work on the transactions. So define new transaction. Now here return. I'm just returning that we will add a new transaction. That so we'll add the logic for this later. Now time being, let's work on this like this only. Okay. So I'm just implementing the templates. Now next is for printing the chain. For printing the chain, that is at app.root, that is /chain, comma, methods equals to get. Now the method next is define full chain. So what it returns is, it returns a response. So I'm taking a response variable equals to as a dictionary, which is chain is blockchain dot chain. Then length of the chain. Length of blockchain dot chain. Right? Now whatever response we'll be getting it in a JSON format, right? Whatever response we'll be getting it in a JSON format. So let's convert it to JSON, right? Return JSONify of response with request code as 200. So this is the response code. Okay, there are certain response codes for JSON or web addresses like 404, 200, 100. So these are all called OK, right?
सर ये जेसन किस लिए यूज होता है?
सर हम जो भी हम वेब से उठाते हैं तो ये कैसे आता है कि जेसन फॉर्मेट में आता है,
Okay.
राइट. सो वी विल बी यूजिंग दिस जेसनिफाई. From Flask, import Flask. JSONify is imported. Let's import from Flask, import Flask. Now, okay, guys, let's import these things that we need for our this one. Comma request, comma JSONify. Are we done till here, everyone? Did we import this line? Guys, make it fast.
Wow.
Are we done till here? Now, are we done here, guys? Now let's come and let me explain from here. Line number 111. So in the line 111, we have instantiated our node, right? That node is of Flask, right? And now, in the next, we are given the name that is for our node, right? Next is in 114, what we have done, we have instantiated our blockchain class, that is object. Okay. Now next, from 121 to 123, what I have done is I have created a mine endpoint, which is a get request. Mine endpoint, which is a get request, right? Then from 126 to 128, we created the transaction/new endpoint, which is a post request, since we will be sending data to it. Guys, understand? Get is to fetch the data, post it to send the data. Understood, everyone? Hello? People?
Yes, sir.
Okay. Now moving on to next. Now next, in the line 132 to 136, what we have done is 132 to not 36, 132 to 138, what we have done is we have created a chain called endpoint, which will return the full blockchain, right? Now next is, let's write this running server, that is if name equals to main. Did you understand why did we use the attribute class attribute yesterday? Because for this, right? If name equals to main, then app dot run, that is here we'll be passing the host, that is host equals to web address, that is localhost. Initially we'll be setting it is 00.0.0 and port will be our 5000. Right? This is the basic option for run method. Done. So let me test it. Add a terminal here. So it opens up the terminal. So it opens up terminal. Let's Python. Python. What's our blockchain with Flask, right? Blockchain with Flask. So here you can see that it is running on the server. So our server is activated, right? So let's check it on the Postman. So let's check it on the Postman. So here when you come to the Postman, here it is to check our web address. Okay. So when I send, what is that option here to mine? It is as for send, right? So I'll take this mine, Control C, and I will paste it here. Control V, and my server is 5000. Now let's run. Okay, see here, I'm getting it. Can you see that? I'm getting that. We will mine a block. Understood, everyone? Now, next is, if I take this transactions new, Control C, if I paste this, Control V, transaction new, so it will send that this method is not allowed for the request. So that is not send, right? This is not get, this is post. So use post, click on send. So it says we will add a new transaction. Understood, everyone? Now next is chain. Guys, always make sure that what type of methods you are sending, get, right? So that what you have to change, you have to select the get and add the URL here. Chain. Now send and see that. Can you see that? I'll get a complete chain here. Proof is 100, timestamp is the time that you created, and the transactions is null. Are we done, guys? Everyone, did you understand clearly, everyone? Hello, people. See, you are getting it in a JSON format. If I run that in the browser also, you copy this code, you copy this and check in the browser. Right? When you run this, you will get that error, right? That is the JSON format. Understood? So that it returns the length of the string, that is 1. Are we clear, everyone? Hello, people. Are we done? Now, next, since we are already a class method for adding transactions to a block, so the rest is, let's write the function for adding transactions. So let's write this function for adding the transactions, right? Now, Here I have this, right? Define transactions, that is values equals to guys, how's it going everyone? Boring. Values equals to request, that is get JSON. Now next is, let's check the, guys you can unmute yourself. Thank you everyone. Now let's check that required fields are, let's check that required fields are in the posted data, in the posted data, that is required equals to, it's a list, that is sender comma recipient and amount Now if not all, so let's iterate over it. K in values for K in required, that return, so I don't want this, right? Return missing values, that is 400, right? Object code not okay, right? So next let's create a new transaction. Let's create a new transaction, that is index equals to blockchain dot new transaction, that is values of sender comma values of recipient comma values of amount, right? Now response equals to, we'll get a message, that is message transaction will be added to block index, right? So returning here, we'll be returning JSONify of response, and message code is 201. So let's save it and test it. This is post, right? Transaction / new. When I send it, I got the transaction, but why didn't I? Okay, transactions new. My fault. That should be transactions new. Control V. Send it. Okay, I need to refresh it. I think, see here, I am getting a message called 200, right? You can see that transaction new STTP1. So I am getting this 200. That is our server is fine. Okay. Now, next is the mining endpoint. Next is, guys, the mining endpoint. Now, the mining point is where the magic happens, and it's easy. It has to do three things, right? It has to do three things again. So let's understand what it has to do. Next is next is okay, the mining endpoint. The mining endpoint. So first thing we calculate the proof of work. Calculate the proof of work. Then second one, reward the miners. Reward the miner, that is us, by adding a transaction, by adding the transaction, granting us one coin. Third one, forge the new block. Force the new block by adding it to the chain. Understood, everyone? So these are the things that we are going to do, right? If you want, you can take a note of it. Now, next, let's go to mine. So what we are doing here? Now, we will run the proof of work algorithm. Proof of work algorithm to get the next proof, right? Now, so last block equals blockchain dot last block. Then last proof equals last block of proof. proof equals blockchain dot proof of work, that is last proof. Right? Now we must receive a reward for this, right? When we solve this, we must receive a reward for finding the proof. That is the sender has mined a new coin. A new coin. Congratulations. Next is blockchain dot new transaction. Here we'll be passing sender equals, initially the address is 0, then recipient node recipient equals to node identifier and amount equals to 1, right? We are done. Are we done, everyone? Clear? Guys, are we done, everyone? So moving on to next, let's forge the new block by adding it to the chain. Let's forge the new block by adding it to the chain, right? So previous hash equals to blockchain dot hash of last block, blockchain of last block, then block equals to blockchain dot new block, that is proof comma previous hash, right? Now after this I'll be receiving a response. So response equals, again it's a dictionary, that is message is new block forged, right? Now index is block of index. Next, transactions. Transactions are nothing but block of transactions. Now Ma'am, what are you not able to understand, ma'am?
बस सब कुछ आ रहा है, जो भी कर रहे हैं सिंपल कंसेप्ट्स हैं, पर किस तरह से मूव करना है, कैसे और क्यों ऐसे ही मूव कर रहे हैं, वो थोड़ा सा कंफ्यूजिंग है चीजें, क्योंकि या तो कंसेप्ट्स पता नहीं है, बेसिकली वही फंडास क्लियर नहीं है या उस पर काम नहीं किया है, बस वही दिक्कत है। वैसे तो इतना कुछ वो नहीं है कि वो कोई चीज
मैम ऐसा है कि ऐसा ज्यादा कुछ हम लोग कॉम्प्लेक्स नहीं कर रहे हैं, ठीक है। ब्लॉकचेन तो बहुत बड़ा कॉम्प्लेक्स थिंग है, मैं इसको जितना सिंपल हो सके उतना सिंपल आपको करने की कोशिश कर रहा हूं, ठीक है। तो हमारा एक कॉन्सेप्ट यही है कि जब भी आप एक ब्लॉकचेन बनाते हो उसमें ब्लॉक्स ऐड होनी चाहिए ना, है ना।
वही लिस्ट
जब एक आप ब्लॉकचेन बना रहे हो,
बिल्कुल वही कर रहे हैं कि लिस्ट बना रहे हैं, तो उसमें हम ब्लॉक्स लिस्ट में जैसे नोट्स ऐड करते हैं, इंसर्ट करते हैं, इसमें हम ब्लॉक्स ऐड करते जा रहे हैं।
हाँ, तो वही कर रहे हैं। अगर आपको एक
सिक्योरिटी और प्राइवेसी
प्रूफ ऑफ वर्क, यस मैम,
उनकी सिक्योरिटी और प्राइवेसी वगैरह को लेके जो चेक्स वगैरह डाल रही है, वो इसमें मेजर इशू है।
मैम इसमें उतना अभी नहीं करेंगे हम लोग, इथेरियम में बनाएंगे। वैसे इसमें इतना कुछ नहीं लिखेंगे, ये हम सिंपल एक लोकल एप्लीकेशन बना रहे हैं, ठीक है। वो होगा थर्ड फेज में, सिक्योरिटी वगैरह होगा थर्ड फेज में, एडवांस में। तो उसमें आपको एक सिस्टमेटिकली लाइक वेब इंटरफेस के साथ कंप्लीट ब्लॉकचेन कैसे बनाते हैं वो सिखाया जाएगा, ठीक है। यहां पे हमको बेसिक कॉन्सेप्ट ये है कि ब्लॉकचेन होता क्या है और ये कैसे काम करता है, वर्किंग ऑफ अ ब्लॉकचेन। सो हियर इन दिस 6 days what we will learn is what exactly is a blockchain, how do we create and how do we work with it, that's it. So here I'll be teaching Ethereum also, introduction to Ethereum, that's it. Now to get in depth of this, we have advanced phases of that. If you want, I can help you with that, how to create and how to work with advanced phases. But as if now,
Yeah, I can very well understand. It's not easy to do that much in a so much small of time. It's not easy.
yeah,
Yeah, madam. Actually, madam, sorry to interrupt you. We do have even second phase and third phase also. So there, we will be covering all these things. Okay. This is the first phase of AICT sponsored program, and even we have even second phase and third phase. There we will be covering all these steps.
Sir, I want to ask one more thing. Will you inform all the participants that are right now participating phase 1?
Yeah.
Regarding phase 2 and phase 3?
Yeah, they will be getting an intimation from madam.
Okay.
Chetna madam, coordinators are there, no? They will be getting it.
Okay, sir. Thank you.
We have even another.
okay guys, everyone, hello. Okay, so considering this, I cleared your doubts. Thank you, Malari sir, for helping me out. Now next is getting the proof, right? After transactions, that is next is proof. Now, so in this proof, what we want? Block of proof of the block. Then in previous hash, this is the same what we did for our previous program, right? Previous hash, block of previous hash. Right? Now lest after this, what will returning? I'll be returning a JSONify response. That is JSONify response with code of 200. Right? Let me save this. Now, next is note that the recipient of the mined block is the address of our node. Why am I getting blockchain here? Error. Too many positional arguments. No worries. right? So next is, note that the recipient of the, where is that recipient? Yeah. So you can see that recipient of the mind block is the address of our node, that is node identifier. And most of what we have done is here is just interact with the methods on our blockchain class. So at this point we are done and we can start interacting with our blockchain. So let me stop this and let's run it again. Now let me check it now. So there is no method. First get, instead of transactions I'll go for mine. Send. Okay, so there is that the server encountered an internal problem, unable to. Okay, so what is that? There's an error here. See, you're getting error code. Mine is get method chain. Let's see what we get for chain. Control C, and I'll try to give it is Control V, and okay. I'm getting a chain of one block, right? So now we're trying to do that. So there is an error with here. Block. Okay, no issues. Mine. Let me check with this mine. Control C and paste it. Control me. Mine is mine. Send method. Okay, there is a problem with this. What is that code? Let me check in the Google Chrome. So server has encountered an internal error and was unable to. Okay, there's an error in the internal, so we'll solve it later as we are running out of time. Okay. Now, are we done till everyone? Guys, are we done till everyone? People. Hello.
Yes, sir.
Now, moving on to next. So next is consensus. Consensus is a very important concept while you are working with blockchain. Right. So let me explain you what is consensus and what we are trying to do in this consensus. So next is consensus. Now, as if now we have got a basic blockchain that accepts transaction and allows us to mine a new blocks, right? But the whole point of blockchain is that they should be decentralized. They should be decentralized. Right? The whole concept of blockchain is they should be decentralized. Right? And if they are decentralized, how on earth do we ensure that they all reflect on the same chain? Right? Are they on the same chain? Do they reflect on the same chain? Right? That's our again concern. So this problem is called as consensus. So checking for whether they are decentralized. If they are decentralized, whether they are reflecting on the same chain. So this process is called as consensus, and we have to implement a consensus algorithm. Consensus algorithm. Right. So if you want more than one node in our network, so let's work with registering a node. Registering new nodes. Registering new nodes. That is, before we can implement a consensus algorithm, we need a way to get a new node, right? Know about neighboring nodes. New node should get info of the neighboring node, right? Nodes, right, on that network. So each node on our network should keep a registry of other nodes on the network. So thus we will need some more endpoints. So what we'll do is we'll add these two methods, that is nodes register and nodes resolve, right? So in this node register, it is what it will do is to accept all new nodes in the form of URLs, all new nodes in the form of URLs, and this resolve is to implement consensus algo, right, which will resolve conflicts to ensure a node has the correct chain or not, right? So we all need to modify blockchain constructor and provide a method for registering a new node. So let's go to our blockchain constructor, right? Now let's go up to the blockchain. Here I have, right? After this, I want to define method to register new nodes, right? So next is docstring add a new node, to the list of nodes, and seriously control X define, guys, you should tell me, right? Register node, that is self comma address, and here control Z, docstring, that is summaries add a new node to the list of node, right? So arguments here are address, and type is address. Arguments नहीं parameters होता है, so it's parameters address, and its type is string, right? And what it address of the node. Address of the node, for example, that is from which address it is created, that is https Guys, can you hear me? I'm sorry. Guys, can you hear me now?
Yes, sir.
Everyone. So what we did here is, so this address is expects the returns the address of the node. That is, example, it will return your physical address. Now here what I'm taking is past URL. So I'll parse that URL by and convert it, right? Convert it to string. Then self.nodes.add past URL to netlog. So let's understand what is this method about. So this method for adding neighboring nodes to our network. Okay. Note that we have used a set to hold the list of nodes. Okay. So this is a way of ensuring that the addition of new nodes is idempotent, meaning that no matter how many times we add a specific node, it appears exactly once. Right? Understood everyone till here? People.
Yes, sir. Yes, sir.
Okay. So we'll stop here. Tomorrow we'll continue with the consensus algorithm because it's a pretty big one. I need to explain what is consensus algorithm, then we'll work on it. Okay.
Okay, sir.
Chaitanya ma'am, Supriya ma'am. Hello. Yes, I'll share the file. Okay, let me share the files.
Sir, how we upload these files? It directly will run, or we have to click
Just
the
it will
mouse?
just directly run, sir. No need to update or anything, sir. It's a .py file.
I have to keep on the same folder which we have in morning created.
Yeah, you have to save it in the same folder. Blockchain work. This and this.
Yes, blockchain
One.
work. Yes, sir.
Okay, file, computer, blockchain with. Oh shit! It went in private window. File, computer, blockchain with Flask. File, computer, blockchain with.
Ma'am, kindly also share morning attendance link.
Guys, I have shared the morning file as well as the Flask thing. Okay.
Yes, sir.
So both the files are uploaded successfully.
Yes, sir.
Rahman sir, yes, you can run it in Spider. Are we done till here, everyone?
Yes, sir. Thank you, sir.
So tomorrow, Anil Kumar sir, I just uploaded that file. Chetna ma'am, in the chat box, Anil Kumar sir, in the chat box, if you scroll up the box, if you were disconnected, then I can't do anything. If you are connected from the beginning, then you will find that chat box. Chetna ma'am, what's not possible? Should I continue now?
Sir, you want to continue for 10 minutes, sir?
Ma'am, your voice is not audible for
Can
me.
you hear me now, sir?
Yes, I can hear you, ma'am.
Okay, you want to continue or you want to stop over here, sir?
Madam, I want to stop here, ma'am, because the next program is pretty lengthy one.
Sure, sir. No worries, sir.
Okay, ma'am.
Okay, sir.
No worries, sir.
Okay.
Okay, ma'am.
Thank
Can
you,
I
sir.
leave now?
Yes, sir. Yeah, sure, sir.
Pleasure, ma'am. Thank you, ma'am.
Thank you, sir. Thank you,
Guys,
sir.
I hope everyone enjoyed today's session.
Yes, sir.
Was it informative? Like, did we enjoy this creating blockchain and all those things?
How we run these files are in a terminal? In
Yeah,
terminal.
yeah. I'll show here how does it actually runs. You should run that in the terminal.
Yes, sir.
Locate your file folder in the terminal and just type Python and the file name like blockchain Flask, right? Like this. So it opens up this running com window. That is, you are running it in this window.
Sir, what
Then
is the
go to this.
Postman, sir? It's the browser of this.
Postman is to receive the URL, sir. Postman is to receive the response from the URL.
So we have to download this also, or it's automatically open?
No, sir. You have to download and install that Postman
Otherwise, we have to run in a browser.
browser.
Okay.
Right? There is an error. Hash takes. Okay, blockchain dot hash. There's a problem with this hash. Understood. That is blockchain dot hash. Last block. Hash takes 0 positional arguments. It means I have to give some positional arguments for hash. All right, where it is. hash. What is this hash? It expects argument, right? It expects a block. That's why I was getting error. Now, if I run this, I should get, there is no error in the application. The server encountered internet problem. Either there is server is overloaded or there is no error. Okay. So post 9 or transactions type error. Argument of none type is not iterable. Where for if not all k in values for k, blockchain with file. Okay. Post transaction. Okay. Here. Okay, are we done, guys? File update blockchain with Flask. I have shared it, sir. Blockchain with Flask, updated one. Okay. Okay, guys. I hope everyone has enjoyed today's session. So let's end this. Okay. Good day, guys.
Thank you, sir.
Ma'am, please share morning session attendance link.
very small. And secondly, because of rain conditions, when it's overcast and then there's too much moisture in the air, or there is a coverage problem, or foliage is there, crop foliage is there, the range will drastically fall. So we set our technology to be around 150 meters. And right now we've given up the P kind of technology, and we're looking at the LoRa kind of technology, which gives us about 8 to 10 kilometers of non-line of sight coverage. So that's our mode of moving forward. What are the type of applications where security plays an important role? Yeah, so as I already said, critical infrastructures, security is important. Process industry, security is important. Smart home, smart cities, this is also security is very important. From agriculture standpoint, I'd say device operations, like farm operations where the drone is flying or something, security is important. So that somebody does not control your drone. And also from the food processing industry kind of thing in agriculture, security is important. But if you're trying to assess the microclimate, I would just give it a low. Yeah. So I think I've answered all your questions. Okay, there's one question. WSL is in the field. Is there any coverage problem? Where to fix the server or procedure? As long as you're getting a good backhaul 3G, 4G connect. I mean, we had an application which would assess the signal strength of the 4G radio. So that is the place where we would put our antenna, our gateway, and the nodes would communicate with each other to get to the gateway. Okay? So as long as you have a point in the field where you have good signal reception for the 4G backhaul, you can put a server at Hyderabad. See, Anantapur was basically about 400 kilometers from Hyderabad. Okay, so as long as we were having a good 4G 3G connection from the agriculture field, our gateway was able to scale that distance and connect to the servers. It is useful for educated farmers only with smart mobiles. Yeah, but we have to understand the landscape in which India is changing. Now, even a laborer in the agriculture fields has a cheap smartphone that's able to do excellent communication and stuff like that. So everybody in the agriculture setting is now moving on to smartphones which are available at a small data cost from the normal feature phone. So it won't be it won't be long since you find that the feature phones will already be out of production, only smartphones will exist. Okay, so even a normal farmer should be able to get your advices on a decent feature smartphone, which is low cost. Yeah. So any other questions?
So there is a question, any energy efficient WSN protocol used?
We had our own energy efficient protocol, so we once published that. It's not that we took somebody else's protocol, and to search the research space of IoT and WSN, there are a lot of people writing different kinds of protocols and stuff on energy efficiency. But as far as our application is concerned, it all depends on how much you want to send, when you want to send the data, and those kinds of inputs. And so we had to develop our own energy efficient WSN protocol. That was able to allow us conserve the battery for about 72 hours without solar power. Okay, so that's our own privilege. Thank you for this opportunity. And
sir, I request you to turn on the camera once so that we can take a photo.
Okay, sure. Thank you so much for this opportunity. Yeah. Can I log off now?
Yes, sir. So with this, we come to close this session. I once again thanks our respected speaker for such a useful session. I also thank all the participants for attending the session. And with this session, we end